Hey, this is Mr. Hanson. I'd like to talk with you about angles and arc measures. There's a relationship there, but before we get too far, let's talk about different kinds of angles in a circle. If you have a center point and you have a radius and another radius, you've made a central angle. So it's called a central angle. You can kind of see why, because it starts at the center. If you have 3 points on a circle and you make 2 segments out of those 3 points, you have what you call an inscribed angle. And you can kind of see that the angle is kind of it's on the end of this, it's on the circle there. So both of these angles intercept what we call an arc. So here's an arc here. It's a portion of the circle, and there's the arc there. And for the central angle, let's talk about this. When we talk about angles in degree major, there's 360-degree angles in a circle, and maybe this angle here takes up let's say probably about 120 degrees. Okay, so the angle measure is 120 degrees. We'll call this point A and point B, and that point C. So angle C is about 120 degrees. Now now think of the arc. Arcs are also measured in degrees, so continually around the circle is 360 degrees, and this portion is probably about 1/3 of that, or 120 degrees. So arc AB is also 120 degrees. So based on that example, we can say that the central angle and the arc measure are going to be the same. They take up the same portion of the circle, one in terms of angles and one in terms of the amount of arc out of 360. All right, so let's talk a little bit about the central angle and the inscribed angle and see how they're related. I have a picture of that over here on the left side of the screen. And I'm going to give these angles some names. So I'm going to call this angle beta. That's a common Greek letter that's used when you're identifying angles. And this one, angle alpha there. And I've used a diameter in this case. It's kind of a very specific case, but so there are other general cases that can be proven, but we're just going to prove it for this case here with the diameter being the side of the central angle and the inscribed angle. Okay, so let's just take a look. We've kind of made a triangle here. Maybe you can see that. I'm going to just kind of highlight a few things on this triangle. Since these are both radiuses, they have the same measure, so we know it's an isosceles triangle. And if you have an isosceles triangle, you're going to have base angles that are congruent. So I'm going to call this angle up here, I'm going to call it beta, because the angle down here was beta. And I'm going to try and label this third angle in the triangle. I'm going to go 180 minus alpha. And maybe you can see a linear pair in here, alpha and 180 minus alpha. Linear pairs are supplements, they add up to 180, so 180 minus alpha plus alpha is 180. So now that I've got 3 angles inside the triangle, I'm going to use the Triangle Sum Theorem. Angle beta plus angle beta plus 180 minus angle alpha equals 180 degrees. And let's do this in black so it shows up a little bit better. So this is 2 angle betas plus 180 minus alpha equals 180. Let's subtract 180 from both sides. And we got 2 angle betas minus alpha equals 0. And then let's add alpha to both sides. And so 2 angle betas equals 1 angle alpha. And if we think about that, it takes 2 of these to make 1 of these. Or we could write it like this: angle beta equals angle alpha over 2. So that's saying that we take the central angle and take half of that, and we're going to get the inscribed angle. So let's just sketch a little circle over here. We've got a center point, and we've got an inscribed angle. It's 100 degrees right there. So 100 degrees. What if we have a point right there, and how many degrees would that angle make right there? Hopefully you can see that if we have angle beta, if we have angle alpha, it's just two angle betas, so this is going to be 50 degrees right there. Now if you knew that this one was 50, you could determine that this one would be 100. It works forwards and backwards there. Just remember the central angle is twice the measure of an inscribed angle, or you could say an inscribed angle is half the measure of a central angle. Okay, let's take a look at one more thing. I'm going to just start new here. If you have a circle and you have an inscribed angle right there that intercepts this arc. If you have another inscribed angle over here that intercepts the same arc, so we'll kind of highlight this one in green, highlight the other one in blue. Okay, they intercept the same arc. What does that mean about their measures right here? This angle and that angle should, since they intercept the same arc, be congruent to each other. So if this was 37 degrees, you would know that this one is also 37 degrees. You could even put a third angle in there if you wanted to. If it intercepts that arc, you would know that that's also 37 degrees. So inscribed angles are defined by the arc that they intercept, and if several inscribed angles intercept the same arc, then they have the same angle measure. Hope this is helpful to you, and have a good day.